Hello and welcome to this workshop on MATLAB COMSOL Livelink. My name is Sefer Askari, and today I'm gonna show you how to work with this Livelink and what are the important things you should consider. My name is Sefer Askari and I'm a simulation scientist at RWTH Aachen University in Germany. Uh, I have been working as a battery designer and battery expert since 2021, too, actually. And I have been using COMSOL and especially COMSOL MATLAB Livelink since the beginning. So I decided to record this short workshop uh, to exchange my knowledge with you. I hope it works and it helps you. I try to do my best, but you should consider that it's a very spontaneous recording and I haven't prepared any material for that because I wanted to show you everything, how it works and how when an engineer faces a problem, how should they solve it. I hope it helps you, and I added my contact. I hope you can contact me if you have any problems or questions. And let's go for the workshop. In the end, I want to, we want to design something like this, but an automated version. Actually, designing something like this is not very complicated in COMSOL. The only complication is using Livelink, and we are not gonna use GUI of COMSOL to make this model. Instead, we are writing the codes, and the code will make this. Sorry for being very like these slides are very basic. I just wanted to record this, so I decided to take the first step. And if I wanted to make more materials, probably I wouldn't record it any time. So uh, let's dive into our problem. Actually, the reason I wanted to record this workshop is that I have been developing a model for as a part of my job, and basically what it does, it has different sheets, which is from cell to system, module and system, and it has some parameters. We can define many things here, and if we change something here, like actually you don't need to understand them right now. I just want to show you how it works. Like if I change it to 10 and 5, don't be shocked for now. I just want to show you how it works and basically how COMSOL MATLAB Livelink works. You have to open it here. It's an old version. We also have the newer version, but let's use the older version for the moment. When you click on COMSOL Multiphysics with MATLAB, it opens MATLAB, but it's connected to the Livelink server. And if you just open the MATLAB and run this code, it won't work. You have to use COMSOL MATLAB Livelink, and you see this here when you open it. So now we are set and it's connected. So actually what I have written is a bit complicated at the moment because it's about 4 months of work, 3 months of work, and it has different options as you saw on that Excel file. But basically this code will go through all the lines in that Excel file. You can see here, I also commented it here, and it will extract the data. Then it will process the data. It will do some processes, and it will design a model. So we can just see the results now. if I run this code and the data is in our Excel file, here you can see that it will read the data. Just okay. Now you see the data is read, and we will have our model open in COMSOL. Yes, actually our design is fully automated and we don't need to do anything. As you saw, I did not add any coding to this. Actually, it's a very basic example. I did not do anything, but it will design everything. I just told that, okay, I need 10. If you saw, I changed something to 10. Actually, 10 was the number of the cells in X direction here, and 5, the other number I changed, is the number of the cells in this direction. So my code is capable of doing more. You can change many things. If I change something here, probably I want the numbers like be 8 instead of 10 and 2 in Y direction, but I don't want the cylindrical cell anymore, but I want prismatic cell. So what it does everything automatically. And now we have another thing. We have 8 cells in X direction and 2 cells in Y direction. So basically it goes beyond this step, and as a very complicated in the maximum part, it's a CAD designer framework, I think we can call it framework. Finally, there are many options that can be turned on. I just turn it on and I have the data. There are some random data that I inserted to check it, but finally it can be very complicated, like designing a whole system, something like this. Yes, something like this, which we have some part for our CSU system, which is cell supervision unit, and we have this BMS for battery management system. Actually, everything in this code can be changed based on what we have in that Excel file, and we can change all the dimensions, and we can change everything here. But the only important part is that you saw that I was changing everything, and it took less than 1 minute for me to show you different examples. If you want to design such a thing, it would take a very long time, and you have to take care of the dimensions, like the clearances, many things. But in this way, you don't have to worry about all these things. You just say, okay, I want 8 cells in this direction, 2 cells in this direction. I want 6 modules, which basically, actually, these boxes are the module. I want 2 modules in X direction, 3 modules in Y direction, and it will design everything for you. Okay, it was an introduction and how COMSOL MATLAB Livelink works. You don't have to work on such a big thing. Actually, it takes a lot of time and effort. If it was easy, it wouldn't take so much time for me. What I want to show you today is making such a small problem, but it can give you an insight, and if you are interested, you can go much beyond that, and you can do what I did basically. But you have to pay attention, and you have to work with this kind of codes for time. But it's not very complicated if you know how this basic model is made. So let's go for normal COMSOL. We want to consider a very basic design in COMSOL. Actually, uh, there are some user manuals for COMSOL MATLAB Livelink on COMSOL website, but they need time, and to me they are a bit complicated. I want to show you, as you see, this workshop is very short, but I tell you that it can solve your problems. You can do anything with this short tutorial. What I want to show you is what basically I found the most important thing, and it helped me very much. If you want to go through the codes and you see they are very complicated, they like defining, actually it's not, yeah, defining the function out model, like you have to know what you should import and what are these lines, what do these lines mean basically. So they look complicated, and they are. Indeed, they are complicated. Don't consider this part. Yes, because they were my calculations. But these are like MATLAB Livelink commands, and you basically you cannot understand all of them. You have to look up the user manual every time. You have to memorize something. You have to check it. It's very complicated. I understand it was my problem, but as I think I'm a bit lazy, I think lazy people find the best solution for that. Maybe if you worked with COMSOL MATLAB Livelink, you have the experience and you know these facts. But for those people who don't have no overview, I'm describing everything. Okay, I just made a 3D. Oh, I think I forgot to tell you, so let me do it again. When we open COMSOL Multiphysics, not with MATLAB, because basically this one just opens MATLAB. I mean the GUI of COMSOL Multiphysics by itself. When we open this, we will have model wizard and blank model, which are you can see in many tutorials. I don't want to go through them and what they do. Basically, I want to make a blank 3D model. This workshop is all about design, like a CAD design. I'm not gonna add modules for materials or study or physics or mesh or anything, but it's not a big deal. When you understand how it works, and I want to show you how it works, so you can add anything to that without any problem. I don't want to make it very long, so basically here you can set the units. And oh, the components 3D, there are other options which I added 3D here. So you can change the dimension, the units, and this everything. Okay, we go to geometry tab and we can have different options. I want to make a block, which is basically a cube. So I want my block has 0.5 meters width, 0.3 depth. It means in X direction, Y direction, and Z direction, and 0.2 in Z direction. Basically, this part is positioning that. It's positioning everything from 0. Like here, it starts from here. But you can change the positioning system to like center. Then the center of your cube will be at 0, 0, 0. So basically it goes 0.25 in x in plus x direction, 0.25 in negative x direction, 0.15 in upper direction, 0.15 in lower direction. Oh, sorry, it's in y direction. Plus y, minus y, but I think you get what I mean. Half of that will be on the top of the z direction, in the positive side of z direction, and the other half will be there. But we will set it to corner. So basically it starts from 0, 0, 0, and it will go 0.5 in plus x direction, 0.3 in plus y direction, and 0.2 in plus z direction. So I make it. So here is 0, 0, 0. You see. Then it went here 0.5, 0.3 as you see here also, and 0.2 as you see here. So it made a very basic cube for me. If I want to do it in COMSOL Livelink, COMSOL MATLAB Livelink, I should write something. I should know how to call all these functions here, define a function, and add everything here. But I tell you, you don't need to do that. How? If you want to save it, you can save this model and it will save as it is. But you can save it when you choose Save As option, and you come here. Basically, it's a model. We can call it block for the moment. If you leave it like this, this will open the GUI of the COMSOL. But we don't want it, and I'm lazy to write all those codes. So I do it in the reverse. I know that I want this block. So first I make this block with GUI, then I save it as a MATLAB file, .m. When I save it, look what happens. And I want to open what I've saved. Block here. And the magic happens. It will make everything, COMSOL will make everything you need. It will call everything which is needed. It will create a model because we didn't change the name, and basically it was a model. So the default name is here. It saves the model path, which you saw that it's here. Basically it's here. You see that you don't need to write this path. Everything is here. It understood where the model is. And if you remember, we added the 3D component. It's reflected here. Create model component, create component 1, which was our component. You see here because we added just one geometry. If you add more geometries, then it will be the second component. Here is component 1, the other one will be component 2. But it's here. True means just making it available, and it's working actually. We wanted it to be a 3D, and it's basically reflected here, like geometry 1 in comp 1, which is the convention of the naming. It's 3. This 3 means 3D. And it has a mesh module, but we don't need it for the moment. Actually, it's basic. It's MATLAB COMSOL basics, like it does it. We did not do anything for that. What we want is here. Actually, it understood like .geom.create blk1 and block, because we named it block. We named it block. Actually, we didn't name it. We can change it here, but it's this one. And there are conventions in COMSOL, like component 1 is basically comp1 to COMSOL. Block 1, COMSOL doesn't have these fancy names. COMSOL understands it and distinguishes this block as blk1. So, like component 2 is comp2. So here it's considering block BLK1 as a block, which was a cube, actually, we know it. So now we have set the dimensions 0.1, 0.5 for x direction, for the width actually, 0.3 for depth, 0.2 for height. Now we see it's reflected here as a list here. And this naming cannot be changed because you cannot add 1 or 2 to that. Its size. Basically, this command sets the size of BLK1, which is our block, to these dimensions. We wanted the base be in corner. So set base corner, it sets the corner, it sets the base to the corner. We can change it to center, and it will, it's like changing this one to center, but currently we leave it like that. Okay, and basically we ran this code. Like I clicked on build selected to make in order to be visible to us, this model be visible to us, and this actually it runs, or it means that clicking on this build selected model. An out model is basically where our function out is done in MATLAB. You see, everything is here. So far so good, very nice. But it's just a basic thing. We want our model have more things. The good thing is that you can do anything you normally do in MATLAB. Like here, if I actually not here, yeah. Actually, I'm reading an Excel file in one of my files. I wanted to find some indexes in my Excel list. So you read the Excel file like a normal procedure in MATLAB. When you want, even if you don't have COMSOL, you will do this. And you can do some calculations inside the function. Some logical calculations, like what I did here, or here, or here, whatever you want. You can do basic calculations. Actually, you see, instead of that size in one of my models, I changed that size, which was very basic here, was 0.5, 0.3, 0.2. I changed it to this complicated looking phrase, which I understand how this naming means, how like what are the meaning of these. To me they are clear, but to you it's not clear. We have a space which means that we go to y direction and we go to z direction. So basically, as you see, it's just the basic command, but we can add many things to that if you want to change the size. So the good thing is that you can do everything normal in MATLAB inside and outside this function very easily. So let's go back to our model. I want to change it to something different. Okay. Let's actually I want to save time, so I'm copying something from before. So I want to ask for these inputs. I don't want to set them here anymore. I want to ask them. Okay, I want it as, why did I choose these ones? These ones are better. Yeah. So I'm just choosing these ones, and now I have it's a bit messy. Height is in the end, width, depth. Actually, leave it, but you understand. Height is here, the last one. Width is the first one, and depth is the second one. But it's a bit messy here. So This is a normal MATLAB command, and it will ask for an input. Then it saves it here. Actually, they are not global. If you know about global and local, as they are defined inside this function, so it means that they are local variables. And if you want to make them global, you can just, in MATLAB, it's easy. You can just define them as global, but I don't need it now. So I leave it here. And okay, we are all done. So I just said it will ask for the input for the width, and it will save it here. Then it will ask for the variable depth, and it will ask for the variable height. They are all here. So far so good. But if I save it, I've saved it. And if I run this command, you will see, okay, it will ask the first question. What was the first question? The height of the cell. The height of the cell, actually it's a cell means cube here. You understand it was a cubic cell. Like I want it to be 2 meters, probably. No, 2 is very unrealistic. 0.5. Width, I want it to be 0.8. And I want my depth be 0.6 maybe. Actually, they are in millimeters. You may ask, we just set our dimension to meter. Why is it millimeter? Because it's here, and I just copied it from another file, another code. So it has no meaning. Actually, our dimensions are still in meter. If I changed it to meter, and I run it once again, I think as it's not set. Yes, actually you can see now it's in meter. So I want it to be 0.5, 0.8, 0.2, anything random. You see, it does not print any. It does not give me this block. It's not changed. And if I close it, don't worry, I close it. And if I add some dimensions, it will give, okay, your answer is this, nothing else. And don't consider these dimensions, they are from my code. If I just clear them, you see there is nothing here. Instead, there is just this ants, which is the MATLAB default variable. And you think, okay, where is my model then? How should I how should I open GUI? There is a command. This command is not printed here. The only slight complication is that you have to just memorize this command, which is basically this command. Oh no, I don't have it here. mph launch. mph launch. It calls COMSOL. mph means multi-physics launch. So if I add it here, mph launch, and I run it, it will ask for dimensions like 0.8 for the height, 0.2 for the width, and 0.3 for the depth. Now we see it's like magic. COMSOL opens. Actually, you have to be in COMSOL MATLAB Livelink environment. If you are not in Livelink environment and you just open it in normal MATLAB window, it won't work. It won't work. We can check it. It will give you some errors related to this command import com.comsol.model because it does not understand what does it mean. But as you remember, we opened this COMSOL multiphysics with MATLAB. Then it works. And you see, everything is done. If we go here, You see the dimensions are 0.2, 0.3, 0.8, which are the dimensions we chose here. Okay. We chose them here. 0.8 for the height, 0.2 for the width, and 0.3 for the depth. Actually, the ordering is not the same, but you understand what I mean. So far so good. We just made a simple geometry without using GUI. So let's change it to another, like we can change it to center. Let's see what happens if we run it again. Oh, we got some errors. What's the problem? Probably the error is with this center. So we change it to corner once again and run it again. It's not working anymore. What happened? Okay, here is a slide. It's an important note. Actually, I mentioned it here also. Oh no, here. You see, the name of this model is untitled, as we didn't save any naming for that. So it's untitled. It's the default of COMSOL MATLAB Livelink. So when you want to recall this function, what it wants to do, it wants to do another model with the default name, which is untitled. So there will be a contradiction. There will be a problem. We have two untitled models which are different, but they have the same name. We have the problem in programming. It's called aliasing. Oh, sorry for aliasing. Yes, means that the naming are the same, but we have two different objects. So what you can do, you can set a name for this model, or you can basically, if you don't need this model, which in our case we don't need this model anymore, you can close it and don't save it. Don't save it because you still have the model. So if I run this code and just center, I want my base be in center, which is 0, 0, 0. And I run this code again, it works again. You see, it opens without any problem with our naming conventions. But look at this. This time it went, let me show you the dimensions. We have 0.3 here. Actually, what it did, here is 0.15, 0.15 here, minus 0.15 here, and it went through these directions evenly, like they are the same. If you want, you can change it. If I change it, I want to shift it 0.15 in this direction. So I don't want any of my parts be in the negative part of the x axis. So if I build it, you see that it's started from 0. You can change it. So let's leave this problem. Actually, we don't want to leave this problem. We want to build our model on this. Something like this, not exactly the cube. We can change it to anything. Like we can do it in a rectangular shape. So let's do it. Actually, I have this code open, this model open, so I don't want to make a model from scratch, and I will use it. So we will have this model. Actually, I want my width be more than my depth. So 0.3, and it's in that direction. Okay. In COMSOL, if you're familiar with COMSOL, you will use one very important command, which is the difference here. Difference. Basically, it extracts something from something else. What I mean, let's see. We had the dimension 0.6, 0.3, 0.2. Is 0.2. I want to make this rectangular cube hollow, and I want to put my cells inside this. So I make a smaller rectangle here, which is basically 0.1, 0.2, 0.1. And I make this rectangle. You see that there is a small rectangle here. But I want it actually, let's let it be 0.5. I want to shift it a bit. So I'm shifting that. And you see this is centralized here. Actually, the other dimensions are inside this cube. We can just, no. How should we, no, not, no, there was something that we could hide this. Actually, leave it. I forgot it. There was something. Oh, yeah, it's here. View all. So we have a smaller cube inside this big cube, and we are gonna use the difference command. Difference. What it does, you have to choose this block, this bigger block, and you can choose the smaller block to subtract it from the bigger one. What does it mean? Let's see. Now you see it's hollow. So it's a very useful command, and we want to use it when we are gonna add something inside a cube, like what I showed you in battery systems. So we have this, and I hope you understand this. Actually, the dimensions are smaller than the bigger ones, and I changed them to be in center, 0.5 in plus direction, 0.5 in this direction, in y direction, and 0.5 in upper direction to be here. You can change it. Actually, we can change it if you 0.7, you change it, but you have to, it gives you an error because it says that, okay, you have this difference and you cannot change it. Then I change, oh, actually, no, it's because this, yeah. We just shifted that a bit. You can just shift this one also a bit. You see, you can work with this. Everything works. So, okay. Let's leave it like this. Now, let's save it and see what happened in our MATLAB model. Now we call it hollow. I hope I don't have any grammatical problem. Block. Okay. Now we are recording this, and let's see what happens. Okay, we have saved it. We have saved it here, and let's open it. We have our hollow block here. Okay, what happened? These are the basic commands that we used before, and they are still here. So they are for every model. If you see my models also, they are there. Actually, they are here. They are basic MATLAB commands. The only thing is different is that I changed my units to millimeter. I use this command, but the other ones are basically the same. So you see there are multiple codes, multiple lines, and it's changed here. Let's go through them and understand what they are doing exactly. So as we talked about these parts, we leave it here. So It creates a block which is BLK1. We know, we just set the size, we want our base be in center, and we run it to have our model there. Then okay, you see something interesting here. What does it mean? Why the base is in corner? Here is the center, and again it will be in corner, center. Where is the other one? Again, I think I changed it. No, actually, it's yeah. But you see why we have many commands. Like we set the position to 000 here for BLK1, and here it's where is it? It's in another position. So what does it mean? It's the second important part which I mentioned here. COMSOL MATLAB Livelink actually records whatever you do when you are making changes inside your GUI. If you do anything here, it will be recorded here. But but the thing is that it will do the last command, what comes in the end. Like here, it sets all this size and base to the center and this position, but it will be overwritten here. It will be overwritten here, and this part is important to Livelink. And if you see, we changed the size also, although the size was defined here. This size is important because it comes after this line. So this is important. It's the last part which is written as the size of that cube. So it's the important part that you should take care of. You may think there are many things like the same. Yeah, like we have this command here, again here, again here. What does it mean? Because we clicked on this build selected multiple times and it recorded all of them. So we can eradicate them, but leave it for now. Let's come to this part. Okay, we made a new block which is BLK2 here, BLK2, the second block. And we set its size, but we changed its size here. And we set its position here and we run it. So we wanted to hide something. You see, even that one is reflected here. We were playing around with this hide button, and they are here. Even those actions are recorded here. And we just run this. We made a difference to have a hollow cube. Here, it's here. And you see selection is input, which was in the difference was this one, input, and BLK1, and objects to subtract was BLK2. You see here, input 2. Input 1 basically was the first one, and input 2 is the second one. Run difference. Actually, we ran it 2 times, so it's 2 times here. But if you delete one of these, nothing will happen. What was that command? mph launch. Okay. And we just close it. And let's see if it can reproduce that file we just closed again. Let's run it. Yes, we have it here. So we want to add something, some cylindrical cells inside this. So I want to use some dimensions, like we will have, you can, oh, actually it's for the position. You can have everything, but just try to be consistent with what you do. Here the width of this one was 0.5, so I just set the radius to 0.2, then the diameter will be 0.4. The diameter is 2 times the radius, and I set the height to 0.15 probably. Then I want to elevate it. It's the bottom will come and stick to here. Then I want to shift it to 0.25, and same for this one. Oh, sorry. Let's see. No, it was not. Oh, actually it was 0.2. So it must be what it must be. It was the depth was 0.2, so we must have something like 0.8, I think. 0.8, but it's in the wrong position. Wow, yo. 0.8. It will be here. If we 0.8, you can change it whatever you want. So I want it to be in the middle, so I just shift it to the middle, and I want it to be in the beginning. So what are my dimensions? I have this dimension. It is started from actually it's in the x direction, 0.5, and I have my radius. So 0.5 plus my radius, which is this one, and it will lead to 0.13. You see, it's exactly here, but I want it to be a bit there. I wanted clearance here, so I just shift it. So let's see what happened to our code. Save it. Basically, we want to save it as our still our hollow box. .m. Okay, it says that there is a model there, and I want to change it. Yeah. No. And I think we have to open it once again. Okay. Let's see what happened here. Okay, we played around with the dimensions many times, and they are all reflected here. So it's your task that you should clear and clean this code. But you see that I changed the position. Oh, basically what it does here, it creates a cylindrical cell, which is CYL1, our naming convention. And it sets the R is radius. The naming of the radius inside COMSOL is R. We set 0.2 for the radius and 0.15 for the height. Then the position, then we run it, then we change the diameter to 0.8 and to 0.08 actually, and we changed everything, and it's here. So the only thing we haven't done, actually the model is different from this, but it's also very basic, and what basically we did are the same here. We have a hollow box, you can make it, we have a cylindrical cell, it's just about positioning. So the only thing left, let's open this model again, the only thing left is that we want to have an array of those cells. Array is another command here. Actually, I want to have like 2 or 3. If I make it smaller, like let me make it smaller, like radius 0.5, then I can shift it to 0.2, I think. Yes, and I want to have 3 of them here. So what I want to do is that I want to go to Geometry tab, and here we had a difference, and you have the other options, but now I want to go to Transform tab and choose Array. We have other options, actually, you see, Array. And I choose this object to be the input of the array. and it says that the array type is three-dimensional, but I want it to be linear. I would just want to go in this direction. Three-dimensional means that it will produce itself in three directions, X, Y, and Z. But I just want to make it in X direction. Don't let linear cheat you, because you may think that it's a 3D model. Why should we choose linear? It's about the type of array, not about the model. So it will be linear means that in one direction. It can be X, Y, or Z. It will be produced in just one direction. And size basically means that how many of them. I want three. And I add a displacement from here, like how much the step should be. I want it to be like 1.5.0, you see. But as our dimension, as our radius, it starts, you can see one important thing. It starts from the middle of the cylinder, because basically all the dimensions are defined here when we set the radius. And as 0.5 is our radius, so they are inside each other. So if we changed it to 1, now they will be outside, but they will stick together, something like this. And if you add more space, you see that they are in position like this. Actually, this dimension is this clearance is more than this clearance, because we just chose the dimensions randomly, so they are not exactly inside in the middle, but you see what I mean. Now for the last time, let's see what happened to our code. Hello block. It must be MATLAB format. We will replace it, and we are all set. So just, yeah, actually it's reflected here. We don't have to open it again. I thought that we have to open it. So you see that everything is like before. We had the cylinder, we changed the dimensions, we set the position, and here is what we add right now. We create an array which its naming convention is array1. Let me just show you once again. Here, the naming convention of array is ARR1. These are the dimensions, these are the naming conventions. These are used in MATLAB COMSOL Livelink. CYL1. You don't see like cylinder 1. You see here is CYL1. It's the coding version. So we have an array with this name. We set the input, what we want to be our input. Cylinder 1, which basically is that our cylindrical cell. And I wanted it to be linear, means that only in Y direction. And I wanted to copy it 2 times. Actually, altogether they are 3, but it copies 2 times. It includes itself, the cell itself, into this number. So when I choose 3, it will be copied 2 times, not 3 times. And it's important. And I wanted the step size be at first this one, then I changed it to this, and every time I ran the code. And you see everything is done. The good thing is that I told you that we can change anything. We can automate this, like if I want to have a modular thing, like I choose it N. I want to be able to change that number of the copied cells. So I can define it here, like N to be an input of how many cells do you want, and it will put it in N, and n will be red here. So if I run it, how many cells do you want? Actually, these times I just want 2 cells, not 3 cells. It will give an error. What's the problem? Okay, we have our model open here. It says a model with tag model is used by another client. We should close it then. Okay, how many cells do you want? I want 2 cells. It prints the n because I didn't comment it out, but I didn't set a semicolon here. You see, now it's 2 times. So actually, I think we have gone through every steps. By this way, you can add anything, physics, materials, and everything to your model. And you don't need to, actually, you need to go through the user manual sometimes, but for the models, like I want to have something like this. First, I make a scratch. I do it in GUI, which is basically very easy. I export it as a MATLAB file. Then I change it. I change everything here inside the MATLAB code. When I have something and it's easily readable, I know what do they mean. So it will be very easy then. And you can define some functions here. And maybe you think that, okay, where is n? N is not here because I told you n is a local variable. It's defined inside the function. And in programming, when you define the function, when you define the variable inside the function, it will not be reflected in the whole model. And the lifetime of this variable n is here. When we go out of the function, n is gone. What you can do, because sometimes you have to, I did it in my code because I needed some variables to reflect some changes in my variables. So I just use the global command. You can also use it here, n as a global n. And let's check it once again. Okay, it has a problem. It says that it must have an end, which is, I think, here. I'm not sure. It must have an end. Then we have to call the function, I think. Oh no, end must be here. Because mph launch is it's a part of the function. Then we have to treat this function as a normal function. And we call the function. Basically, you can call the function something like this. I want to, yeah, I have the end. You can call the function and if I'm right, now we have it here. We have our n here, but we don't have any numbering for that because we are not calling our function. Sometimes I also I forget many small things. How to, but we have ChatGPT and Google. How to call a function in MATLAB. Function in MATLAB. It's very easy. Just search whenever you want something. Okay. What? Oh, it's printing too many things. I just wanted a very simple thing. Why it's going through all these steps? I don't know. Actually, I'm a bit confused. Sometimes it happens when you are doing something advanced, but you are confused with very small things. Like now, I have this function out. Okay, I have to call it here, I think. Hmm, calling, yeah, calling the default function. I think it should work. Ah, oh, oh, it's not working. Okay, it works, but n is not there. Still not there. Yeah, but you get what I mean. It's basically because of the naming conventions I did it. I don't know what's the problem with this one now. Global n. It must be reflected here, but I don't know why. What's the problem? But you can Google it to see what happens here. Global n might be unused or unset. Okay, I think there must be. Okay, leave it because it can go beyond. But if you have something like this, which I have in my model, I define something global, then it will be reflected here and you will have your n here also. I hope you enjoyed this tutorial and I'm gonna end it here. We didn't make this file, make this model, but we tried to fix it somehow and we made something like this. But these are the important nodes. First, I told you that every action you do, it will be reflected in the .m code, the output, the MATLAB output. But it will be overwritten. Whenever you change something, it will be overwritten. So be careful that don't be confused first. Then, when a model is made by by Livelink, it has the default naming. And if you don't change it and you want to run your code again, and the model is open there, which is it's called untitled by MATLAB by COMSOL by default. If you don't change the naming and you open it once again, it will give you an error due to aliasing. And take care of the naming conventions, especially in large models, which is basically what I had. I had a hard time with these naming conventions because they can be easily confusing. You don't know what are the variables, what should you do. If I show you in my code, I have tons of, oh, actually I closed MATLAB. I have tons of functions for T functions. So I calling them are a bit hard. So take care of this in the first step. And then when you go and you proceed, you can have a better overview of what your code is doing exactly. Thanks for your attention and I hope you enjoyed. You can do everything else with this way, in this way, and it's about 2 years, more than 2 years of my experience in battery design and working with COMSOL MATLAB, Livelink, and MATLAB by itself. So you can share it with your friends, or if you liked it, uh, I hope you liked it, you can like it, or write to me basically when you have some problems. I hope I can ask you as soon as possible. Actually, I will reply you as soon as possible, but sometimes, most of the times, I'm very busy. So sorry in advance, and have a very good day. I will close this and I hope you enjoyed this video.